Hello and welcome all on Unacademy JEE English channel, guys. And today I'm Rahul Kaushik. I'm going to take lecture number 7, Sequential and Parallel Equilibrium. So, guys, we have already covered 6 lectures, and the agenda of today's class is to cover sequential and parallel reaction. And along with that, guys, I'm also going to cover just a minute. And along with that, I'm also going to cover phase diagrams. Okay, guys, just a minute. There is some echo. Now there will be no echo. Okay, guys. So let's start it. Hi, Ansab. Hello, everyone. No, Ansab, it's in NCRT by the name of chemical equilibrium itself. You can see it. Sequential and parallel, as such, there are no topics in NCRT. But when we will be doing ionic equilibrium, this topic will come over and again. Okay. So before we start today's class, guys, let me introduce you. I'm Rahul Kaushik, and I worked in Banza classes for continuous 10 years. And during my tenure there, guys, I was head of department, and I mentored 2000 plus IITs. Okay, guys. So this is all my brief introduction. And other than this, guys, I have also co-founded my own organization, Zigyan Education Private Limited. And now, along with Zigyan, I'm also teaching here on Unacademy, India's largest and fastest growing online platform. Okay, guys. So now let's move ahead, guys. We are also there on the Telegram app, and the name of our channel is JEE English, and you can subscribe to that channel. And the link for that channel is given in the description part of this video. Okay, guys. So now there are some simple steps how you can subscribe to Unacademy, guys. Yes, step number 1, just go to Play Store or App Store, download Unacademy's learning app. Once you download it, guys, install it, and after installing, you will be reaching onto this page. So, guys, on this page, just click on the plus. Once you are clicking on the plus, you will be getting these options. So, guys, choose your goal. And if you are preparing for IIT JEE, guys, then choose IIT JEE. And after that, guys, hit the subscription button. Okay. Once you are hitting the subscription button, you will be directed to this page. Here you have to choose a program either for 12 months or for 24 months. So guys, don't forget this code Rahul game. If you are applying this code, guys, you are going to get 10% off. And now I will tell you about the fee structure. For 1 year, you have to pay 38,000. For 2 years, you have to pay 34,000. Sorry, 56,000. But guys, if you are applying my code, then instead of 38,000, you just have to pay 34,000, and instead of 56,000, you just have to pay 50,000. Okay, guys. Yes, it is essential for everything. Actually, I'm giving it a different topic name. It is basically the real equilibrium is this sequential and parallel equilibrium. So Kavya, it's very important because you cannot solve ionic equilibrium without simultaneous. They don't write this name over and again what is simultaneous equilibrium, but it's important, guys. Right? It's important. So now I'm moving, guys. This is Rahul game. Yes, Rahul game. Just remember this code. So you might be thinking, what are the advantages of joining Plus? So I'm going to tell you guys. On the Plus, your course would be purely structured, and along with the structure, guys, what you have to, you are going to get there. I'm telling you. Every fourth class, guys, every fourth class will be doubt clearing session, and after that, you will have weekly quizzes, you will have live quizzes, and once your topic is over, guys, then you will have a mega quiz over that topic. Okay, so guys, there are so many things which you can get over there. Okay, guys, and you will have access to not just my video lecture but the video lecture and content of all the educators who are teaching there for IIT JEE. Suppose you have chosen IIT JEE, then you will have access to all educators there. Okay, guys, So these are all the benefits. So guys, let's start today's class. So are you ready for it? Are you ready for it? So let's start it guys now. Chemical equilibrium, lecture number 7, sequential and parallel. So before this guys, I'm going to take phase diagram. So this is the equilibrium, like we compare it. This is equilibrium constant, this is reaction quotient if Q is less than K and if Q is greater than K. So now you understand it. We have covered this point in the previous class. So guys, now I will discuss the physical equilibrium. What is physical equilibrium? So when we are talking about physical equilibrium guys, there will be actually no, what should I say, there will be actually no chemical change, right? And if there is no chemical change, what will happen? If there is no chemical change, what will happen? Suppose guys, for physical change I am here taking, let me take here, yes, this is water. I'm taking pink color water, and if this is water guys, yes, these are vapors. So ultimately a stage will reach when your water and vapors will be in equilibrium guys. Okay, and when they are in equilibrium, you can say rate of evaporation will become rate of condensation, right? And in such a scenario in chemistry, what we generally say it in chemistry, I call it like if I'm taking H2 liquid and it is converting into H2 gas. So guys, at equilibrium, the forward reaction is evaporation, okay guys, and the backward reaction is condensation, right? So forward is evaporation and backward is condensation. So if I'm saying Kp guys, yes, what will be the value of Kp here? So Kp will be partial pressure of H2 and this is the pressure at equilibrium. So Kp will change only when temperature changes and I call it vapor pressure. I call it vapor pressure. And in the previous class I told you that if forward is endothermic, so increase in temperature favors endothermic, so K will increase. As T increases, this Kp will increase. Why? Because because reaction is endothermic. So guys, why I'm telling you this, suppose here I'm making a graph between temperature and vapor pressure. So what will happen when I'm making the graph between temperature and vapor pressure guys? What will happen? So let's take it, these are all the dots, because when you are increasing the temperature, Kp is increasing, and if Kp is increasing guys, if Kp is increasing, what will happen? If Kp is increasing, vapor pressure is also increasing, so this is the vapor pressure. So let me make it like this way, this is the graph for vapor pressure. And guys, here you can observe as temperature is increasing, vapor pressure will also increase. Got it? As temperature is increasing, vapor pressure will also increase. And if this is going to increase, what will happen? If this is going to increase, guys, what will happen? This line will be like it only. Similarly, guys, you can make a graph. You can make a graph between ice and its vapors. Right. Okay, guys. So, guys, here you can see this is the Kp, guys. And Kp means this is partial pressure of H2 again. This is vapor pressure, but this is the vapor pressure of this is the vapor pressure of ice. This is the vapor pressure of water. So for ice, if you are making this, it will be like this. And here I can say this is the equilibrium between liquid and gas. And here if I plot the dots, then I would say this is the equilibrium between solid and gas. Okay guys, so here you can see it. This is the equilibrium, means below we have gas, above we have solid, here we have. Similarly guys, we will have a line where that line will represent the equilibrium between solid and liquid. Every point every point on this line represent equilibrium between solid and gas. Okay guys, are you getting it? Tell me, are you getting it? Any doubt? Any doubt? No doubt. So what I'm saying here, this is called phase diagram. And guys, in this diagram, this is called triple point. At this point, solid, liquid and gas, all three are in equilibrium. And guys, here we have liquid in this region, we have gas in this region, and we have solid in this region. So if you are in this region, it would be ice. If you are in this region, this would be gas, vapor, steam. And if you are in this region guys, it would be water. It would be water. Okay guys, and if you are getting it, this is water head. I hope now you got it. Now you got it. So why we call it triple diagram? Because at this point, solid, liquid and gas, all three are in equilibrium. Getting it? So guys, vapor pressure of solid I have also explained you now. H2 solid converting into H2O gas. So this will give you vapor pressure of solid. Okay guys, so this is called triple point diagram. This is called triple point diagram. Any doubt? So I'm again making it, and this time it will be a bit larger. This is vapor pressure guys. This is temperature. And if I'm plotting the graph between vapor pressure and temperature guys, what will happen? Now you should know the region. This region we call liquid. This region we call solid, and this region we call gas. Got it? So this is the equilibrium between liquid and gas. This is the equilibrium between solid and liquid, and again this is the equilibrium between solid and gas. Guys, here this whole region is gas. This is liquid and this is solid. Now can you tell me what do you mean by boiling point? Anyone? What do you mean by boiling point guys? So just note it down. Boiling point. So boiling point would be guys, it would be the temperature. Which temperature guys? So let me tell you, once you are increasing the temperature, vapor pressure is increasing. You can see here, temperature is increasing, as a result, vapor pressure is also increasing. So once you increasing the temperature, vapor pressure is increasing. And if vapor pressure is increasing, what would happen? What would happen? Now I will tell you, if guys your vapor pressure is increasing, ultimately a stage will reach when vapor pressure will become external pressure. And if external pressure is 1 atm, then I will call it normal boiling point. And if external pressure is 1 bar, then I will call it standard boiling point. So what is boiling point? It is the temperature at which vapor pressure of liquid becomes equal to external pressure. Vapor pressure of liquid becomes equal to external pressure. Okay, guys. So it is the temperature at which vapor pressure of liquid becomes equal to external pressure. Got it? So when I'm saying vapor pressure become equal to external pressure, here if external pressure P external is equal to 1 atm, then it will be called normal boiling point, right? And if P external is equal to 1 bar, then it will be called standard boiling point. So guys, you can get the boiling point from here. Suppose this is 1 atm. Corresponding to this, you will be getting boiling point, and this boiling point will be normal, right? Here a question arises, which boiling point is higher? Even in NCERT, one statement is there, standard boiling point or normal boiling point. Yes, guys, tell me. Yes, Ansab, Kavya, anybody. Can you tell me which boiling point will be higher? No, normal boiling point or standard boiling point? Tell me, guys. Which boiling point would be higher? I'm getting no answers. Hi, Avindas. Which boiling point? Is it normal boiling point or standard boiling point? Which one is higher, guys? Kavya, Avindas, Ansab, anybody, can you answer me? That is important question. Even in NCERT, we have a statement over it. So, guys, here I will tell you. Here I will tell you. If this is 1 atm, then 1 bar will be slightly less than it. Let me take one more color here. Yes, and this temperature, this boiling point is called standard boiling. And again, standard boiling point will be always smaller than the normal boiling point. You can see it from the graph, because 1 atm is equal to 760 torr, and 1 bar is equal to 750 torr. Got it, guys? Any doubt? Please tell me. No doubt. So is that clear now? So here I can write, guys, please make proper notes. Normal boiling point is greater than standard boiling point. And now there is one more point, guys. If you are going to increase the temperature, if you are going to increase the external boiling point, suppose external pressure become 2 atm, then what will be the boiling point? So on increasing the external pressure, boiling point will increase. Note it down. Boiling point will increase on increasing what? Boiling point will increase on increasing temperature. Sorry, external pressure. Note it down, guys. Boiling point will increase on increasing external pressure. Any doubt? No doubt? Got it? So note it down, guys. Avindas, that's very difficult for me. Actually, I'm specifically IIT teacher, so don't know much about these cutoffs for NEET. But it looks your score is very good, and you can get a very good percentile. Yes. Hi Priya Bajaj. Hello everyone. So Let's move ahead, guys. Now let's move ahead. So boiling point is done. Now what is the melting point? So guys, I'm telling you in the graph itself, this is the melting point, and we call it normal melting point. We call it normal melting point. Okay guys, because this is the melting point at 180. Again, if you are going to change the external pressure, your melting point may also change. Yes, if you are taking external pressure 0.518, then guys, this would be the melting point. Although difference not be much, because when you're making it, it would be very small. But this is the normal melting point. So at normal melting point, the Weber pressure of solid and liquid will be same. So note it down. What is melting point here? It is the temperature at which Weber pressure of it is the temperature at which Weber pressure of liquid becomes equal to solid. Got it, guys? So it is the temperature at which Weber pressure of liquid becomes equal to solid. Any doubt, guys? Please ask. Any doubt? Yes, Avindas, Kavya, Priya, anyone? No doubts? So guys, melting point is the temperature at which Weber pressure of liquid become equal to solid. Weber pressure of solid. Got it? So now you know the melting point, and again, if you are going to increase, the external pressure, boiling point is increasing, but melting point will decrease for water. This diagram, this is called phase diagram, and this diagram is for water. Okay, guys, and here I can write on increasing external pressure, guys, what will happen? Melting point of water will decrease and boiling point of water will increase. Yes guys, did you get my point? Tell me if you have any doubt. Any doubt? No doubts, guys? Okay, so now let's move. So this is the actual diagram for water, guys. Here you can see, and I just told you that if you are increasing the external pressure, suppose 280, melting point will decrease but boiling point will increase. So this 100 degrees Celsius is normal boiling. This is the triple point, guys. At this point, solid, liquid and gas, all three are coexist and all three are in equilibrium. So you will get this point, and pressure would be very low at this point, right? Any doubt? So what is the difference, guys? This is diagram for water only, because in case of water, if you are increasing the external pressure, melting point will decrease. But guys, other than water, it will be like it. This will be the solid region. Yes, you can see it. This is the liquid, guys, and this is the gas. So this is solid, liquid and gas. Got it? And if this is solid, this is liquid, this is gas, this line is like this. So can anybody tell me the impact of this line having slope like it? Like it? You can see it. Can anybody tell me? Yes, guys. Why this slope is like it? Why? Nobody. So I'm going to tell you the significance of this slope. Actually, now, if I talk about If I talk about boiling point, so this is boiling point and this is freezing point. Suppose now I'm increasing the temperature. Sorry, this is 1 atm, I'm increasing the pressure. This is 2 atm. Now what will happen, guys? What will happen now? Tell me. The thing that will happen now, yes, I'm going to tell you, boiling point will increase at new pressure and melting point will also increase. But in case of water, what was going on? In case of water, when you were increasing the pressure, melting point was decreasing, but boiling point was increasing. So guys, this is the main difference. This is the main difference between the boiling point and melting point. Anyone, guys, anyone, tell me if you have any doubt. No doubt. So now let's move to the next point, solubility. So what do you mean by solubility? Actually, there are two types of solubility. For ionic compounds. For ionic compounds. Like you might have seen the sugar. Sugar is non-polar. So what is sugar? Every one of you have seen the sugar. So C12H22O11. This is solid. If you are mixing it with the water, you will be getting aqueous. So what does this aqueous means? Tell me, what does this aqueous means? Tell me, guys, what does this aqueous means? Now the sugar is dissolved. Suppose I am taking a glass, having water, and guys, these are sugar pieces at the bottom. Now if I'm taking the stirrer or a spoon to stir it, what will happen, guys? If I'm taking the spoon, I'm telling you, after some time you will observe that in this water we have these particles will be distributed everywhere, small particles, and I will call it hydrated. Or if some other solvent is there, then I will call it solvated. Okay, guys, so this is the ionic compound. This is for non-ionic. And if I'm taking an ionic compound like NaCl, guys, so if NaCl I'm taking, on dissolution it will dissolve into ions and it will give me Na plus aqueous and Cl minus. So what will happen? If NaCl is there, suppose NaCl solid is there, right? So NaCl is salt. In Hindi we call it namak. ये namak है and every one of you have seen this namak. So when you are going to stir it, what will you get, guys? So when you are going to stir it, you are going to get Na plus Cl minus. In this case, this whole molecule was intact. So this is dissolution of solid in, these guys tell me, solid in liquid. So when a solid dissolve in liquid, suppose I am taking a solid and I am dissolving it in water, and it is going to give you a aqueous. Okay, guys, and it is going to give you a aqueous. So this process can be exothermic or endothermic. It depends, actually, many factors, and I'm going to discuss all those factors in thermochemistry. So it can be endothermic or exothermic. So guys, if dissolution is endothermic, if dissolution is endothermic, it means on increasing the temperature, if forward process is dissolution and backward process is condensation, if this is endothermic, so increase in temperature will favor endothermic and backward will be exo. Right, guys? So if dissolution is endothermic, it means on increasing temperature, solubility will increase. Okay, and in the next part, if dissolution is exothermic, guys, then on increasing temperature its solubility will decrease. On increasing temperature, note it down, solubility will decrease. Yes, you got it. Any doubt, guys, please ask. No doubts. So actually I cannot comment if there is a statement like solubility of solid in liquid, and I'm going to increase the temperature. What will be the impact? I cannot say. First I should know whether it is endothermic or exothermic. You might have seen in your at your home, like when you are dissolving the sugar in the water and water has become saturated, you cannot dissolve more sugar. But if you are increasing the temperature, if you are increasing it, what will happen, guys? And if you are increasing the temperature, you can dissolve more and more sugar. Why? Because, guys, I'm telling you that dissolution of sugar in water is endothermic. So if you are increasing the temperature, it will favor it. And if it would have been exothermic, then on increasing temperature, solubility would have been reduced, guys. Solubility would have been reduced. Okay. Any doubt, guys, please ask. No doubts. So now I'm moving ahead, guys. Solubility of gas in liquid. So what do you mean by it? Solubility of gas in liquid. So when you are dissolving a gas in a liquid, then how will you do that? Yes, how will you do that? I'm telling you, suppose this is water, and now I'm taking a pipe, and through this pipe I'm dissolving the gas. So gas molecule will be dissolved. Not always, but in general, I'm telling you that dissolution of gas in liquid is exothermic. Okay, guys. And if dissolution of gas is exothermic, suppose I'm writing a gas plus water, it is giving you A aqueous. And if I'm saying that this forward process is exothermic, so backward would be endothermic. So guys, tell me, if I increase the temperature, in which direction reaction will move? Are you ready? Tell me, guys, in which direction reaction will move? Any doubt? So guys, if I'm increasing the temperature, increase in temperature will favor endothermic. Which formula ready? Increase in temperature will favor endothermic reaction, and it means reaction will move in backward direction. Reaction will move in backward direction. Got it? What is the vitriol? You can Google it easily. Right now I'm not teaching chloroform, vitriol, but actually it is blue vitriol. We call it CuSO4.5H2O. This is called blue vitriol. Got it? Got it, puppy? Ready? Okay. So now you answer me this question. Yes, guys. How will you determine densities of diamond and graphite are given, guys, here? Let's see who can answer it. This is the formula. So just do it now. Just solve this formula. Be fast. Anyone? So guys, till this point we have done Lee-Chatelier's principle, and Lee-Chatelier's principle, what I told you, if you are increasing the pressure, reaction will move in a direction where number of gases moles are less. But here the problem is, what is the problem? Tell me. But guys, here the problem is there is no gas. Diamond is a solid and graphite is also solid, right? So there is no gas. So how will you answer it? How will you answer it? Tell me. Yes, ready, I will answer your formula. But before that, answer this. No, Mr. Unacademy. No. Anyone else? So guys, now I will tell you. You can answer these questions. You can answer these questions only depending upon the phase diagram. How will you answer it? Now I will tell you. When there is a gas, there is no problem. But when we have solid and liquid, there is no gas. So suppose I'm saying H2O liquid and H2O solid. This is ice. And can you tell me in ice and water which is having higher density, guys? In ice and water which is having higher density? Yes, family home. So guys, density of water is greater than density of ice. Density of water is greater than density of ice. Why I'm telling you? Here, if you are at the equilibrium point, suppose I'm here, right? And if here I'm getting it, what will happen? So if you are increasing the pressure from here, if you are increasing the pressure, I will move here. And actually this is in general. And if I take it for water, let me take it for water. For water, I'm telling you first, solid and liquid. So if I'm here, guys, and if I increase the pressure, so I will be here, and this is the reason for liquid. It means reaction will move forward. And if I decrease the pressure, it means I will move to solid, so reaction will move to the backward. Okay, guys? Please tell me any doubt if you have, guys. Please ask me, guys, if you have any doubt. Any doubt. Please tell me, guys. No, no doubt. Anyone? So why I'm telling you? Okay, Papi, ready? It is H2SO4 if you are talking about simple H2SO4. But are you cheating somewhere? Okay. Who is this Amijit Medi? I think. Is it you, Papi, ready? So guys, what I can say, in this case on increasing the pressure, more liquid is being formed and density of liquid is greater than density of solid here. Right? In case of water only, otherwise in general, density of solid is more than the density of liquid. Okay. So here guys, if I'm talking at this point in general, if you are increasing the pressure, we are reaching in this region and more solid will be formed. So in one line I can complete it like increase in pressure will favor or will direct the equilibrium in a direction where density is high. Note it down, guys, it's very important. Yes, it's very important. Now I have told you the explanation for it and you will never do wrong. Increase in pressure will favor that direction Where? Which direction, guys? Increase in pressure will favor that direction where density is more. Okay, so now let's solve it. The favorable condition for formation of diamond. So diamond is having density 3.5 and graphite is having 2.3. So if I increase the pressure, more diamond will be formed. So high pressure is required and the forward process is exothermic. You can see this is negative. So backward will be endo. So increase in temperature will favor backward. So I can say high temperature and high pressure. So your answer would be C. Right? Your answer would be C. Yes, guys, now tell me. This was really a very good problem and most of you cannot answer it easily. So let's move to the next point, guys. Now do it. Yes, Unacademy, they are sufficient. Don't worry about it. You can go through any other lectures. You will not find such a detailed way of lectures. So, guys, addition of water to which of the following cause the ship to move backward? Can you tell me? Anyone? So I will discuss all these problems. I will discuss, but before that, let's start. Let's start first. Simultaneous equilibrium. Yes, your high temperature was right, but there was option having high temperature and high pressure. So the correct option was C. If options were there, you could have told me about the option. Okay, Unacademy, Mr. Unacademy. So guys, what do you mean by simultaneous equilibrium? Now I'm going to discuss it. What do you mean by simultaneous equilibrium? So here guys, I'm taking a simple problem and that problem is, suppose here I'm taking X and here I'm taking Y, right? So when you are dissociating X, it is giving you a gas A gas plus B gas and Y is giving you E gas, C gas. Okay guys, and suppose here I am getting X, here I am getting Y. Okay, so if I talk about the equilibrium, I will be getting here B gas plus A gas, and this A gas I am also getting here and C gas. So here guys you can see A gas is common. Instead of it, there should be equilibrium, right? So guys, if I'm asking you one question, like if what will be the expression for Kc? This is solid. So will you write x square and this is Kc1, suppose this is Kc2. Will you write x square and y square, guys? Please tell me. Okay, Unacademy. Now just listen to me. Is it right? Is it correct? Is it correct? Tell me, guys. This is not correct. Actually, in this container, I am having three gases A, B, and C. Only three gases. And A, whether it is coming from this or whether it is coming from this doesn't matter because the properties of A will be same. A can be oxygen, A can be nitrogen, A can be hydrogen. So what will happen, guys? What will happen? Now again, I am telling you, if this is A and A I can get from any of this, and if I'm getting A from any of it, so it is wrong to write. We should not write this way. How should I write? Actually, the A will be x plus y and it will be x plus. And when I'm writing, yes, Unacademy, you're right. When I'm writing Kc1, it would be x plus y into x. Kc2 would be again x plus y into y. So guys, I am going to write concentration of A, concentration of B, concentration of A, and concentration of C. And in this case, I am going to tell you that this concentration is that concentration which is present in the container. It has nothing to do with whether it has come from X or it has come from Y. It should be that amount which is present in the container. If it is liquid solution, then you have to take the, suppose there is H plus and that is coming from two acids. So you have to take the total H plus present in the solution. Yes, Unacademy, you are right. Right? So this is the concept of simultaneous equilibrium, when simultaneously a single product is formed. So let's solve a problem over it, guys. Do it. Do it. Anyone? I'm waiting for your answers, guys. Tell me. So guys, we have two solids X and Y that dissociate into gaseous product at a certain temperature. So pressure over excess X is 40, excess Y is 60. So right now it is saying that both are present in different containers. So in A part I would say this is X, this is Y, guys, and this X is giving you A gas and C gas. This is giving you B gas and C. So when you are writing, when you are writing it, so X solid will give you A gas, C gas. If this is P1, this is P1. So total pressure would be 2P1, and it says the total pressure over here, and it is 40. So P1 you will be getting 20. So what will be the Kp1? P1 into P1. P1 square, that is 400. Got it? The value of Kp for two reaction in mm, so it would be Kp mm square. Similarly, it says that for second one it is 60. So if I am writing Y solid, and it is giving me B gas and C gas, P2, P2, right guys? So what will be the value of 2P2? So it would be 60, P2 would be 30. So Kp2 would be P2 square and it would be 900. So guys, the first answer, I'm not saying that X and Y are together in a container, they are separate. They are separate. No, it would not be 2:3. Okay, B you are saying. The ratio of moles of A and B in the Weber state over a mixture of X and Y. Now there is a problem, guys. Now what they are saying in the B part, they are saying we have taken X and we have taken Y. Now this has become a problem of simultaneous equilibrium, because X is giving you A gas and C gas, Y is giving you C gas and B gas. So there will be C and B, but this time this C has two sources. This C has two sources. It is coming from X as well as Y. So let's see. Let's see Unacademy how many of your problems are right. So first one you did not answer. You directly answered B and C. So I will check it now. X solid, and if X solid is giving you A gas, C gas, okay, and Y solid is giving you B gas and C gas. Now there is one problem. This P1 was the pressure when it was alone. Now it is not necessary. But one thing is clear, because temperature is constant. So Kp1 would be 400, Kp2 would be 900. Okay guys, this is not going to change. This is not going to change. So here, if I'm writing again, suppose I'm writing P1, P1, P2, P2. This P2 and this P2 would be different. So I should write P1 dash, P1 dash, P2 dash, B2 dash. Because now it depends. Kb will be same because temperature is not changing. Okay, Unacademy. So now what will happen? This is B2 dash, this is B1 dash. So you will write Kp1 is equal to P1 dash P2 dash. Now divide it. So it would be 4 is to 9, right? And if it is 4 is to 9, what will happen, guys? If it is 4 is to 9, what will happen? So this is the pressure due to A, this is the pressure due to B. Now they are asking the moles of A and B. So guys, pressure due to A will be mole of A RT by V. Pressure due to B will be mole of B RT by V. So temperature and volume is same. Why? Because the container is common. Their volume will be same. So the ratio of their pressures will be same as their molar ratio. So Unacademy, your answer was wrong. It should be 4 is to 9. It should be 4 is to 9. Yes, Unacademy. Did you get it? So this was the problem on simultaneous equilibrium. This was the problem, guys. Tell me if you have any doubt. Any doubt? No doubts? So now, guys, let's do the third problem. C part. Now I'm giving you some time. The total pressure over X and Y. I think Unacademy now you can solve it. To solve the C part correctly, I am giving you sufficient time for that. Solve it. Okay. So now total pressure. What will be the total pressure, guys? P total will be equal to partial pressure due to A, partial pressure due to B, and partial pressure due to C. So what is the partial pressure due to A? P1 dash. What is the partial pressure due to B? P2 dash. And what is the partial pressure due to C? It is P1 dash and P2 dash. So it would be P1 dash plus P2 dash. So if somehow you calculate the P1 dash and P2 dash, your problem would be solved. So you already know the ratio of P1 dash and P2 dash, that is 4 is to 9. So there are two variables, P1 dash and P2 dash, and there are two equations. Now you can easily solve it. If you add, suppose this is expression 1, this is expression 2, if you add them, what will you get? P2 dash. Now take it common, and if you are taking it common, it would be P1 P2 square. So you will directly be getting as 1300. So 2 into under root of 1300 mm. This will be your answer. Yes, Unacademy, did you get it? Tell me. Tell me, Unacademy. Very funny name. But why don't you guys use your own original names? Why don't you guys use your original names? So guys, now let's move to the sequential reaction. Now, what is the sequential reaction? Initially, I was taking simultaneous or parallel reaction. Parallel means something that is going parallelly. So, what is sequential here? So, when I'm talking about the sequential, yes, what is the difference between parallel and sequential? Can anybody tell me? Okay, I will tell you guys. I will tell you. So, suppose I'm taking X solid and it is giving you A gas plus B gas. Okay, what happens now? Suppose this A gas further gives you D gas. Okay, guys. Suppose this A gas further gives you D gas. So what will you get? What will you get? Tell me. Initially, if it was X1, it was X1. Let me change the color. X1 and X1. So KC1. But now this is not X1 anymore because this X1 is further moving into Y1. So in the container, if this reaction is going on in a container where we have X solid, right? Yes, parallel take place side by side, and sequential means one after another. Sequence. So if I'm saying X solid is giving you A gas, B gas. So again, when I'm writing A gas and when I'm writing B gas, it will be the concentration of A present in the mixture. It is not that A that is coming exclusively from X. It is the overall A that is left. So if it is reacting here, I have to subtract Y1 here also. So I will write guys here X1 minus Y1 and it would be X1 and KC2 would be Y1 over X1 minus Y. Got it? Yes, Unacademy, you are right. So what is your name, Mr. Unacademy? So this is what I'm showing guys. So there is nothing different, but you have to keep in mind if you are doing X minus Y here, you have to do here also. Because this A and this A is not different. Actually, this is the same A which is present in your mixture. Right? These are not different, guys. These are not different. Tell me if you have any doubt. No doubts? No doubts, guys? Okay, so now I'm moving ahead, guys. Let's do this problem. Do it. Solve it, guys. Okay, Karthik. Now, Karthik, solve it. But Karthik, this time there should be no error. This time there should be no error. Yes, do it. Hi Aditya Sehgal. Now solve this problem. This is something related to sequential equilibrium, and you guys can do it. Solve it. Yes, Karthik. Are you solving it? So, if this is P1, now here TB is given. Calculate the pressure of CO gas in ADM when excess of this and this. Excess means they are never going to get exhausted. They will always remain there. CO is also there. Calculate the pressure of CO gas. Okay, I'm giving you time, don't worry. I'm giving you time. Do it. Do it, guys. Be fast. So, what? How do we start it? If this is P1 here, if this is P1, so here I will write P1. Now, if x goes here, it would be 2x. It would be P1 minus x. Okay. So, if you are getting it, so you will just write P1 minus x. That's very funny and very logical thing to do. And sequentially, you are step number 2 and I am step number 1. Right? Right? Now do it. So it would be partial pressure of CO square divided by partial pressure of CO2. So if it is P1 minus x, so again I will write here 10 is equal to 2x square over P1 minus x. And from here I can directly put P1 minus x. And it would be 4x square and it would be zero point 0.4 here. Right? And if it is like it, guys, yes, how can you do it? X square would be, I think it would be 1. X would be 1. So they're asking calculate the total pressure. Calculate pressure of CO gas. So this is CO guys. So pressure of CO would be 2x, 2 into 1, 280. I hope you got it, guys. You don't have to do the complete problem. Yes, yes, Karthik, you are right. Yes, you are right. Okay. Any doubt? Any doubt, guys? No doubts. So let's do one more problem here. Let's see. This is something related to Lee Chadley's principle as well. Do it. Do it, guys. Do it fast. I'm waiting. I'm not getting any answers, guys. See. Let's see, guys. Let's see whether it is C or not. So, for the following equilibrium in a closed rigid vessel, A gas giving you B and C, D giving you E and B. B is common here. Now, if you are introducing some E, if you are adding some E, what will happen? This will move backward, and if this is moving backward, guys, then concentration of B will decrease because this will also move backward. No, D gas is being formed. Okay, okay. Some E is introduced the new vessel, then the concentration of A. What will be the impact, guys? Hi, Aryan. So, what will be the impact? E gas, C gas. So, these are the two equilibriums, guys. Right now, what will happen? If you are adding E, so this reaction will move back as a result. And if it is moving back, concentration of B will decrease. And if concentration of B is decreasing, it will decrease here as well as here because this is the common B present in the solution. No, Aryan, second drop is not good. Yes, and I'm going to take session over it. So second drop is not good. And we have to check. I should have other information about you as well. Only then I can answer you. For that, I'm taking a special session on Sunday. You can join me. Yes, on Sunday, I'm taking a special session. 11 a.m. 11 a.m. on the app, on the Academy app. You can join me. You can catch me there. Or I will be taking it on 2:30. Right? So definitely I will be taking that session. Whether you should go for drop or not, and what are those factors which you should consider before dropping. Okay, guys. Any doubt? So you will be getting here. Hi Osho. So on 11 a.m. Sunday I will be discussing it. So guys, I was telling you that this B is common. This B is common. If this B is decreasing here it will also decrease. And if this B is decreasing, this will move forward. As a result, concentration of A will decrease. So it was really a very good problem. And I think one student gave me the right answer. That was Karthik. Yes, Karthik, you were right. Actually, that is work under process. Digital board is here. but I cannot use it. I don't know how to do settings. And once those settings are done, then definitely I will be teaching there. So guys, let's do this one. This is interesting problem. Actually, this problem involve concept of sequential as well as parallel. Both concepts are covered in it. So let's do it, guys. Tell me. Do it. I will give you sufficient time for it. At least 2 minutes I will give you. Yes, Osho. Aryan. Just try this problem. Karthik. Do it. Do you need more time, guys? Please tell me. Or should I start it now? Yes. Should I start it now, guys? Okay, I'm giving you 1 minute. Actually, this is the problem which is involving sequential concept as well as parallel reaction concept. Okay. So should I start it now? Yes, guys. Okay, now I will start it. So what will happen? You have 1 mole of A gas. It is introduced in 1 liter vessel and it is rigid. So volume is not going to change. And the vessel is maintained at constant temperature, guys. So the following equilibrium is achieved. And at equilibrium, the pressure is twice. And it means, guys, if you take 1 mole of A, pressure is twice. So now total mole of A are 2. And if they are 2, guys, yes, A gas. AC2. Okay, guys. So if 1 mole is given, then I know that at equilibrium total moles are 2. How do I know that? Because initially pressure was 1 atm. Now the pressure is twice. If volume is constant, PV is equal to nRT. Volume is constant, R is constant, T is constant. Only moles are changing. So Here I will take guys 1 mole. Here I will take 1 mole. Something is my, so if it is 1 mole guys, so it would be 1 minus x. Now what would happen? This x will give you y. So if here x minus y, I will write here x minus y. And x and y, it will be x plus y. That's why I'm saying it is sequential as well as simultaneous. So that's a very good problem. So what will be the x1 here? X plus y and x minus y, and it will be 1 minus x. And it will be guys x plus y into y over x minus y. Got it? So now there are two variables, but you have, no, there are three variables actually. X, Y, and even I don't know about KC1 and KC2. And they want the ratio of these two. So how can we solve it? So we have X and Y. So guys, one thing is clear that total moles are 2. So what will be the formula for N total? N total are 2 because initially it was 1 mole and now pressure has become twice. So total moles are 2 now. So total mole will be equal to mole of A, mole of B, mole of C and mole of D. So mole of A is 1 minus x, mole of B is x plus y, mole of C is x minus y, and mole of D is y. So y will cancel, x will cancel. So 2 will be equal to, so guys, x plus y will be equal to 1. Yes. Tell me if you have any doubt. Tell me guys if you have any doubt. So yes, there is one more ratio. C at equilibrium. Now C at equilibrium, what is this? X minus y over B at equilibrium, and it is x plus y. So 1 is to 5 will be there. So from here you can solve 5x, 5y, x plus y, 4x, 6y. So x over y will be equal to 3 by 2. So you can write x is equal to 3 by 2 1. So y will be 2 by 5. Y will be 2 by 5 and x will be 3 by 5. So you got it guys, and just put these values here x and y and you will be getting here only. So when you are saying kc1 over kc2, yes, you will be getting as x minus y 1 minus x y a. Just do it. I think now you can get it. Okay guys, just put the values of x and y and your ratio would be 4. Yes, Karthik, you have committed some error. It should be 4. It was really a very good problem, conceptually as well as in every way. So just note it down, its solution. Note down, guys. Okay, any doubt? So guys, let's do this one. So there is one more problem here. Let's do this. It will be 4. There might be some calculation error. You can verify it. So x minus y, it would be 1 by 5 square, and 1 minus x, 2 by 5, 2 by 5. 5 will cancel out. So kc1 by kc2 is 1 by 4. So kc2 by kc1 would be, you have to avoid such calculation errors. Okay, Karthik. So let's start now doing it. Solve it. Now solve it. This one is easy, guys. Do it, be fast. Yes, I'm waiting for your answers, guys. Be fast. Shall I start it now? Tell me, guys. So here it says the equilibrium N2 and O2 is established in a reaction vessel of 2.5 liter. The amount N2 and O2 taken at the start are respectively 2 moles and 4 moles. Half mole of nitrogen has been used up at equilibrium. The molar concentration of nitric oxide. So this is nitric oxide, guys. So let's start it now. N2 gas, O2 gas, giving you 2 NO gas. P is equal to 0. 2 mole of N2, 4 mole of O2 are taken. Half mole of nitrogen has been used up at equilibrium. So half means 1. 3 mole, 1 mole and 2 mole of it are there. Okay, guys. So total we have 6 moles. So what will be the molar concentration of nitric oxide? So molar concentration of nitric oxide will be moles of nitric oxide upon the volume. So if this is 2 and volume is 2.5, 4 by 5. Yes. Got it? The amount of N2 and O2 taken at the start is 2 and 4. Half mole of nitrogen has been used up. Half a mole of nitrogen. Okay. No, guys, this is half a mole. So 0.5 mole, not half of the initial. I have read it wrong. So it would be 2 minus 0.5, 4 minus 0.5, and it would be 1 mole. So 3.5 mole, 1.5 and 1 mole. So concentration of NO would be 1 upon 2.5. It would be 0.4 mole. So answer would be B. This is half a mole. It is not half of the mole of N2. So always read it carefully, guys. Even teachers can commit errors. Right? Yes, Asha Rani, that is also good if you can do it. That is great. Yes. So let's do the next problem now. Solve it. Solve it quickly. Some quantity of water is contained in a container as shown in the figure. So as neon is added to the system at constant pressure, so the amount of liquid water in the vessel, do it. Yes, do it. Okay, okay, Karthik, let's do it. So now I'm going to start it. Some quantity of water is contained in the container as shown in the figure. So these are vapors and here it is water. When you are adding the neon gas, what will happen? This piston will move away. So as a result, if water is at equilibrium, guys, so you will write H2O gas. Okay, you will write H2O. Okay, guys. So if you are writing H2O here, so this is Kp is equal to partial pressure of H2O. So what will happen when that piston will move upward? That piston is moving upward, guys. This will decrease, and if it will decrease, Q will decrease. Q will become less than K. And if it is so, guys, reaction will move in the forward direction. So what will happen? So the amount of liquid water will get converted into gas. As a result, guys, it will decrease. So amount of liquid water in the vessel will decrease. Actually, volume over volume, this reaction is having no control. It can change its mole, it can change its amount, mass, but volume I am changing. So reaction is not having hands. उसके अपने हाथ नहीं है, so that it can pull the piston. So it can just oppose the other things. Whatever changes have been occurred, it will try to compensate that. Right? It will try to compensate that. Got it? Just tell me now. So guys, this is all for today. This is all for today, guys. If you really like this lecture, guys, then share it and like it, and just click on the bell icon so that you can get latest notification of our lecture. Okay, guys. And we are also there on the Telegram. You can join us, and the link for our channel JEE_English is given in the description part of this video. Okay, guys. And once you are done with it, there are some simple steps how you can join us, guys. Just go to Play Store or App Store, download Unacademy's learning app. Once you are downloading it, install it, guys. And after installing, click on the plus. Once you are clicking on the plus, just check the IIT JEE box. Once you are checking it, just hit the subscription button. And after hitting it, guys, you will be getting it. For 1 year, you have to pay 38,000. For 2 years, you have to pay 56,000. But don't worry, guys. Just remember my code, Rahul Kim. If you are applying it, you will be getting a flat 10% discount. And instead of 38,000, you just have to pay 34,000. And here, instead of 56,000, you just have to pay 50,000. And guys, in lieu of that, you will be getting unlimited access to video lectures, content, test series. There would be live quizzes. Everything would be there, guys. Everything would be there. Yes, you need practice. So I will take one more class on the DPP, right? And I will discuss the problems. Okay, guys. So this is all for today, guys. Take care of you guys. Bye bye. I'll meet you again in the next class with many new different concepts, many new things. So thank you guys. Take care of you.